Hi, I'm Nigel Griffiths, I work in IBM Power Systems Advanced Technology Support in Europe. In this shared storage pools movie, we'll be looking at what happens if we have a total machine failure and we want to recover a shared storage pool client to another machine. How easy is that to do? How long would it take? So let's keep it to a nice simple configuration. This will work just as well with dual VIO servers and lots of clients on the source and target machines. We have one VIO server here on each machine and one client, and at the back end we have a shared storage pool and a set of disks. It's actually on a V7000, but that's not terribly important, and we have the logical unit disks down the bottom. Of course, the client virtual machine just sees a virtual SCSI disk at the top, and then wow, bang! The entire machine collapses, big catastrophe in the computer room, and wow, we had a lightning strike to one of the machines in here. Completely halted the client and the virtual I/O server, and the machine's just dead. Let's face it, it's gone. It's smoking with water pouring through the back of it. Okay, so what can we do to actually recover from that situation? So we want to recreate this client virtual machine. So what information do we need? Well, the CPU settings and memory size is the first thing that's obvious. If the HMC still exists and is accessible, then we can get that information from there. If not, then we'll probably find any performance tools that we were operating will actually have that information as well. nmon certainly does. Tivoli monitoring will have that. PM for power systems will have that. Even the free tools like LPAR to RRD or Ganglia will have that information. Typically we don't have hundreds of networks in a computer room. We have a limited set, and we should know the network that we're connected to for that virtual machine, probably by what it was actually doing. If not, we hope we got the documentation from the network guys or our standard config. Now the disks, that's a bit trickier. We could have 1, 2 or 100 disks in here, and we have to work out where are the disks. Well, hang on, we got a VIO server over here, and that's still connected to the same storage pool, and it can equally, as the dead virtual I/O server, see all the logical units in the pool on the disks. And if we got a sensible naming convention, so we can work out which disks were attached to our now dead client virtual machine, then we can pull those same logical units into a new virtual I/O server. Now, if you've got 1 or 2 disks, we can probably boot off either of those. If we've got lots and lots of disks, then we do have to remember which are the boot disks, and so make a point of that when you're creating logical units to either put that in the name or document that somewhere so we can know how we can boot. Of course, you could try trial and error, but that's not the recommended thing to do while your service is down and you're trying to recover it as quick as possible. Let's step through each of the activities then to recreate this logical partition. Well, we're actually going to have to create a logical partition, set the CPU and memory, and connect up the virtual network or networks. We could, of course, do that ahead of time. That's particularly nice, so that if each machine we have, we can say, okay, if this machine fails, these are the critical LPARs, and decide in advance where we'd actually run them as an alternative. We can actually create those logical partitions. As long as we don't start them, they're not going to use any resources up, but that will save us having to do any thinking while we're having an urgent situation. Next, we're going to have to connect up the logical unit disks, so that we have the disk space allocated. We can do that in one of 2 ways. On the HMC graphical user interface, we can list the LUs in the pool, select one, assign it to our new client virtual machine, and go around in a loop. Or we can actually log onto the VIO server and use the make backend device from storage pool command, as you can see at the bottom. Cluster name and SP storage pool name will be the same every time. The BD option is the name of the logical unit, and the vAdapter, of course, is the VIO server end of the virtual SCSI connection to the client. And we'll have to run that command several times, once for each of the disks. We could actually do that ahead of time as well, so that we're all ready to go. It does need to be quite specific and get the right disks and maintained if you add disks to the original LPAR. The next thing we have to do is to start the new client virtual machine to SMS mode and set the boot disk, because these are new disks being assigned to the client. They'll all be non-boot disks, and we have to select which one we actually want to boot from. Again, we could really do that in advance as long as we don't actually boot from it while the original is actually running. but that's optional on your part. We do need to know which of those disks is going to be the boot disk. Then we have to do a reboot. Now this is where I put very dangerous up against this one. When we do the reboot, we will have to make sure that the original client virtual machine is not still running. Well, if the machine's on fire, we know that for sure. The extra thing we have to be careful of is that we don't reboot that older machine and it has automatic restarts of the virtual I/O server and the client virtual machines, then we could end up with the client running against one set of disks on two different machines, and I'm pretty sure that will mess up the disks within a few seconds, because we'll have duplicate caches in the file system caches of some of those boot blocks, and then they'll mismatch when we actually write them to the disk. So we do need to make sure that the original client can't run once we've started it on our new target machine. But having said that, this is all pretty easy to do, and if we do a little bit of preparation, we can do this in a minute or 2 minutes at the most. Of course, if you've got hundreds of LPARs that you're trying to cover, you want to do them quickly and get through them as soon as possible so you can get your services back up and running and your users happy. Now, it's probably taken me 2 or 3 times longer to explain this than actually do it, so we'll actually go and do it now. First, we better go through the various components of the demo, otherwise you may get lost on what's going on. We have 2 machines called Gold and Bronze. On the Gold machine we have Gold VO Server 1, which is hosting the Gold 2 logical partition. On the same shared storage pool we have Bronze VO Server 1, and there's an LPAR, well a shell of an LPAR running here called Gold 2 Reborn, and we use that for the recovery. Gold 2 actually has 2 disks, Gold 2A, which is the boot disk, and Gold 2B, which has a different volume group and the file system / data. We'll actually write a little program that, or a script that outputs data into the disk so we can see how much that survives. Then we'll actually stop the Gold 2 and Gold VO Server 1. We use the Halt-Q option. It's frightening that most systems administrators actually know this command. Hopefully they don't run it too often. I could actually unplug the power supply on the machine to fake this crash. That's not such a good idea, because actually our power supplies are so good that they actually run for some time even when the power cable's removed, and they actually send warning emergency signals to all the operating systems, which will immediately flush all their disks to try and save their data. So that doesn't actually show us a proper crash. Because Gold 2 is purely virtual, has no real disks of its own, all its I/O and its network is going through the VO server. If we actually Halt-Q the Gold VO Server 1, that actually does cut it off from the real world, and then we can do a Halt-Q on Gold 2. And then that will look much more like we've actually stopped it very hard. In actual fact, the Halt-Q actually calls the operating system from which it never returns. It hands the resources to the hypervisor and stops it immediately. Now on the recovery side, we have those 2 disks to recover, so I'll do those 2 disks in 2 different ways. The first one will actually log on to the Bronze VO Server 1 and assign that first disk with the command. These are the 2 commands we can run in here, lsmat-all, very famous, and then we can look at the storage pool to find which logical unit disk we want to connect. The second one, and here's the command, the make backing devices storage pool command. The second one will actually be, we'll actually use the HMC to do the same thing but graphically, so that proves quite effective and quick when you're trying to recover. Then we'll start the LPAR in SMS. It hasn't got a boot list of any sort, so we'll have to select the right disk and we'll start the LPAR. Finally we'll look at how much of that file was written out. So here's my HMC. In the middle we have the regular Gold, and Bronze at the top is the recovery machine. Here's Gold 2, our LPAR that's going to have a dreadful accident. If we just click on it, we can have a look at its resources. Hardware, it's half a CPU, memory 2 GB, and the I/O none at all, so this is pure virtual. Look at the virtual adapters. Here's our virtual Ethernet and our virtual SCSI. We can see the virtual SCSI is connected to the Gold VO Server 1 and its adapter, virtual adapter 12, slot 12. If we take the machine level here and click, then take configuration, virtual resources, and virtual storage management, we can get a quick view of our shared storage pool and how it's connected. So we'll query the only VAO server we have, Gold VOS1. Here we go. So all of the LPARs are not using local disks on the VO server. If we click this little button here, we can see the shared storage pool information that is connected to the Gold VO server. So here we have Gold 2A and Gold 2B connected to the Gold 2 logical partition. The different sizes, the boot one's 16 and the data one is 8 GB in size. So let's get ready for our disaster. I've opened a few putty screens in here. This is Gold VO server 1. I've gone to OEM setup env so I can type in the root only halt-q. Here's Gold 2, and again we're ready with the halt-q. Up here I'm going to run a script which is going to go around a true loop as fast as it can, appending the date output to a file called temp.xxx, and then it's going to display it on the screen so we can see what's going on. There's no sleeps or waits in here, so it does run as fast as possible, hopefully outputting to that file as it goes. There we go. We can see it running a couple of hundred date stamps a second. So here's a Gold VO server 1. Because it's a pure virtual LPAR, if we stop the VAO server first, that will cut it off from the network and the disks immediately, so it can't save any data as it's running, and that will actually take the VAO server down like a real system crash. Up in here then, a split second later, we'll actually halt-q the LPAR. So there's a complete, halt complete and halt complete. If you replay the movie very quickly, you'll see it carried on outputting for a couple of seconds, just buffering up the writing to the disk, but it couldn't actually get it to the disk because the VO server had already gone. If we look at our machine on the HMC, the LPAR's gone pretty quickly because it doesn't have a lot of resources. The VO server halted, of course, and now we have the hypervisor trying to clean up, releasing the CPU and memory and a lot more virtual resources for all those LPARs I previously shut down because I don't really want to damage them. Okay, so there we are. VO server is not active. We've had a disaster. Our machine has stopped. Now we're going to look at our bronze machine up the top in here and start our recovery. If we look at our Gold 2 LPAR in here, and the hardware here, we have one CPU, so that's a bit more CPU. That won't hurt. 2 GB of memory, that's the same. No adapters. I look at the virtual adapters and it has a similar sort of thing. The same Ethernet segment is being connected up, and we have a virtual SCSI connection to the bronze VO server, and that's the virtual adapter slot 17. So let's have a look at the shared storage pool, see if that's been connected up to Gold 2 already. I don't think it has, but we'll go and check. So again, here's the virtual storage management, bronze 1. The bronze VO server is actually using its own disk to support the clients. Nothing in here to do with the Gold 2 Reborn LPAR. If we look down in here, we can go and find the Gold 2. These LUs disks are not connected to the bronze VO server 1. So we'll do that in a minute. We'll first of all use the command, and then we'll do that on the HMC, just to give you a bit of both. Normally I'd only use one or the other. Here's a window then on our bronze VO server. Let's do an ls map -all, classic command. Just so happens at the bottom, this is the VO server slot 17, and the important thing to note is there's no virtual targets found in here. Nothing's connected to the VO server end, and it's vhost 5. We'll actually use that in a second. Then let's look at the storage pool and just pick out the Gold LU disks. So this is the lssp list storage pool command, and we're just going to grep for a Gold. And so we can see the resources there. Right at the top in here, here's the Gold 2. A and the gold to B. We need these names in here. Actually notice that I did a thick provisioning for the data blocks in here, so it's 100% used and unused. Now we use a command to connect this first gold to A to our vhost 5. So here it is, the make backing device from storage pool cluster storage pool vdisk gold to A and the vAdapter vhost 5. Notice there's no size in here, so it will just reconnect the existing one with the right vhost 5. Okay, that's it. We can do the same sort of thing on the HMC. We actually have the right panel here. Just move it up a bit. If we did a refresh, we'll find that this will be connected in here. But if you just click on this one here, it always worries me that it scrolls out off the bottom. So here it is again, the gold 2B, and we just modify assignment. It says, okay, who do you want to connect that to? Gold to reborn. Okay, and we'll just let it do that, and then it will requery the VO server, so it gets the current settings. And if we scroll down here, so now we have the two logical unit disks assigned to our new LPAR. It has something that it can run on, and we're ready to start it up. So back to here, and we'll select our LPAR, and we want to bring it up. Operation Activate Profile. You've probably seen this 100 times before, but we'll open a terminal and stop in SMS. Okay. Here we go. Select this console. Yep, it's hit 0. Goes around exploring what it can find. Starting up the SMS. And the first thing we'll do is select those boot options. So go into 5. We need to configure because we want it to remember and come up the next time the same way. And we'll do display current settings. And we've only got the inter-partition logical LAN. So it's going to do a network install. Well, that's no good. So we'll go back. So we'll select boot device 1, and then we'll just ask it to list all devices in here. So we'll go around saying, what have I got? Okay, now it's selected in here the SCSI disk because it's actually found that it has AIX 7.1 on it, and it hasn't given us my data partition. So that's helping me to boot off the right disk. Now, the only trickier one is if you've done an alt boot install, and you could actually have two disks you could boot off. One will be older than the other one, so you do have to get that right. So I actually want to boot off that disk, so we'll select 2. It can give me a little bit more information about that with a 1. See if there's anything in there that helps. Not particularly. It's a virtual SCSI device. Okay, I'll do an escape to come out one level, and we'll set that as the boot sequence 1. Okay, now I can come out of here and it will just boot off that first disk. I'll do an X, and it says, are you sure? You can see a little propeller here running. So we're actually booting off that disk. And we're coming up. Now for a very quick look in here, we may actually find it replaying some JFS2 logs as it comes up. But we're up. Okay. Root. And my secret password. And things are still starting up with the subsystems. Gold 2. It's the right guy. If we do a DF, we can find our data. Logical volume group. Still some more services starting up. And if we had an application or a database running on here, then we could start that up, or it might do that automatically. If we look at the end of that file that we were outputting to, xxx, we can see we got up to 11:02 and 5 seconds. Now I replayed the movie that I captured, and the halt of the VO server happened at 11:02 and 13 seconds. So we have 6 or 7 seconds worth of data missing. Now remember, when we're just outputting to a plain file, this is cached by the AIX file system, and AIX, if it's not told to, will automatically flush, I think it's once a minute, out to the disk to keep the disks the same as what it has in memory. And of course that shouldn't be relied upon if you've got important transactions, and this is exactly why your database and applications do sync or flush operations on the disk, particularly the database logs, to ensure it actually gets out to the disk so we don't miss some transactions. But for plain files that users are operating on, there can be a few seconds worth of data missing. Okay, we recovered with the JVS2 log, and then we've recovered what we can from what was actually on the disk, and it's quite easy. This movie is coming in at about 25 minutes or so, and I reckon we could do the whole thing in 2 minutes per LPAR, probably less if we got a bit organised. So here's my little summary. Really cool technology. If you do have big production workloads, then you really should have Power HA, or HACMP as I still call it. For other workloads, or if you can't go for Power HA, if you move to the shared storage pools, then as you've seen, we need to create a matching LPAR, attach the shared storage pool virtual disks, which is a one-line command or a couple of clicks on the HMC, set the boot disk and start the LPAR, and you're up and away. And we can remove all that complexity of resetting LUN accesses or rezoning, all of which causes delays when you're trying to recover from a serious problem. So after I finished making this movie, I thought, well, what does happen if you run both LPARs, in this case Gold2 and the Gold2 Reborn, at the same time on the same disk, the logical unit disk from the shared storage pool? Well, first of all, I don't recommend you do this, and I'll show you why. I actually started them both up and just left them running overnight. I came in the morning and they were still running. I wasn't doing very much, just a few daemons sitting there, no applications running. So I decided, well, let's shut down the Gold2 Reborn and see if there's any problems with the Gold2 just running by itself now. I rebooted it and it rebooted successfully, so that was a good sign. Remember, I haven't done very much to the file systems and things, and I thought perhaps I got away with it. Well, if we're going to have a look at the machine, we'll find it's not quite true. So here we are back on Gold2. Everything seems to be working okay. Remember, I only just started AIX on the other LPAR. It did nothing apart from I stopped it suddenly at the end. Seems to be fine. Then I thought, well, let's actually check our file systems with a good old Unix style file system check, FSCK, and in particular var and temp. I was thinking that AIX would write some little log files, maybe creating a few more of those and deleting a few, and making temporary files in /temp. So I actually ran it on other file systems and everything was okay, but oh dear. /var, we have inode has references cross-linked, so inodes appear in 2 different files. Should be impossible, that is corrupted. And in /temp we have a different error here, that the check allocation map isn't right, and it says it's corrupted. Now, we have them actually running at the moment, so FSCK can't attempt to fix those. Some things are actually impossible. It would just have to say, okay, we have files over here, we don't know what they are, or it says, hang on, we've got 2 files allocating the same bit of disk, and so we'll have to just break the files to actually fix that. This is somewhere you really do not want to go. You'd have to boot off a CD or from a NIM ISO image, and to get into sort of single user mode with the root volume group unmounted, and then you could run FSCK to get these fixed up if you're lucky. So just a little word of warning there, don't go here, here be dragons. If this is a real life database or application running, and it was creating lots of files, we could end up with complete scrambled egg on the file system. The only safe thing to do is to go for a backup, and of course that could take you many hours to recover from, and you'll be down for a lot longer, so do not go here.